Microplastic contaminant in Bivalves. Assalamualaikum, and my name is Akasha Deni Irwan. Today I want to talk about introduction for environmental impact of microplastic contamination in bivalves. Microplastic is a tiny plastic particle less than 5 mm. They are sourced by cosmetic, clothing, and breakdown of larger plastic. For the marine presence is found widely in oceans. Bivalves like mussels, oyster, and clams. For the impact on bivalves is physical harms like blockage and feeding structure damage. For the human health, concern is seafood consumption of risk ingesting microplastics and toxin. Thank you. To continue the environmental impact of microplastic contamination in bivalves. Microplastic contamination in bivalves affect the ecosystems, food chains, and human communities. Addressing this issue involves reducing plastic use, improving waste management, and researching microplastic effect and solution. Tackling the root causes can lead to healthier marine environments and sustainable future. There are many impacts for the microplastic contamination in bivalve, such as ecosystem health, water quality, and economic impact. For the ecosystem health, they have two: biodiversity loss, disturb food web due to reduced bivalve populations. Second one is habitat degradation, alter habitats affecting marine life. For the water quality, pollutant carriers, microplastic absorb and release toxic chemicals. And for the economic impact, fisheries and aquaculture and tourism. For the fisheries and aquaculture, economy losses from reduced population and health risks. For the tourism, decline in coastal tourism due to contamination. Thank you.
Hello, my name is Muhammad Ishamuddin Fazli. So I'm going to tell all of you about the sampling method for this topic. The first one is the direct collection from habitat. We will get into the field and collect live bivalve from their natural habitat, such as mussels bed, or oyster reef. After that, we will use the dredges and nets for this task. And next, we will ensure sample indicates bivalves actively purifying water and possibly eating microplastic. This approach provide a snapshot of um, microplastic present within the bivalve tissues at the time of collection. Next, the sampling method that we will use is the market purchase. Alternatively, we might purchase bivalve from commercial sources like fishery market. This method can be useful to investigate microplastic level in bivalve ultimately consumed by a human, while not directly reflecting plastic contamination in the environment. It sheds lights on the potential human exposure routes through seafood consumption. Following either collection method, we employ specific procedures to dissect the bivalves and meticulously extract microplastic from their digestive system. This extracted microplastic then undergo further analysis to determine their size, type of polymer, and abundance. So that's all from me. Thank you.
Now, for my part, I will be explaining about the extraction method for the microplastic in bivalve. The first method we have is chemical extraction method. which we can do it in three ways. And the first one is enzymatic digestion, second one is acid digestion, third one is alkaline digestion. For the first one is enzymatic digestion. In this digestion, the reagents included is proteinase K to break down protein in the bivalve tissue, and another one is lipase to target lipids and fats. Also, there are a few protocols that we must follow. As for the first one, the preparation, we must weigh the homogeneous bivalve tissue sample. And then for the digestion part, we must add an appropriate volume of enzyme solution. For an example, we can add the proteinase K at 1 milligram per milliliter. And then we need to incubate our sample at 50 Celsius for 24 to 48 hours in a shaking water bath or incubator. And after all of the process is finished, we have to ensure that complete digestion of the organic matter. And if needed, we can do additional enzyme can be added and incubation can be extended. Also for safety purpose, we can use personal protective equipment such as gloves and lab coats. And not to forget, we must work in a controlled environment to avoid any contamination for our sample. Next, for the acid digestion part, there are two reagents that will be included. The first one is nitric acid. It is used for the breakdown of organic material. And the other one is the hydrogen peroxide. It- The use of it is to enhance the digestion by oxidizing organic compound. Next, there are a few protocols that we must follow. The first one, from the preparation, we must weigh the homogeneous bivalve tissue sample. Next one, in the digestion, we must add our concentrated nitric acid, for example, 65%, to the sample in a ratio of 1 to 3 of the sample. And lastly, we must do the neutralization, where once the digestion is complete, we must neutralize the solution with a base, for example, using natrium hydroxide before proceeding. And for the safety part, we must handle the acid with extreme care and use PPE while performing the procedure in a fume hood. Next, for the alkaline digestion, the reagents that will be used is potassium hydroxide for digesting organic material. Other than that, we can also use the sodium hydroxide. For the protocol, the preparation, as always, we must weigh the homogeneous bivalve tissue sample. And for the digestion, we must add our potassium hydroxide solution to the sample. And then we going to the incubation part, where we will incubate our sample at room temperature or slightly elevated temperature around 40 degrees Celsius for several hours to overnight. And then lastly, for the completion part, we must ensure all organic material is digested. And for the safety, we must use PPE and work in a well ventilated area as we are using a basic solution. Other than chemical extraction method, we have another two method, which is by density separation or filtration technique. So for the density separation, we are following a principle that are based on the density difference between microplastic and organic material. Microplastic usually have a lower density than most organic and mineral particles. So the high density solution that we can use is zinc chloride and sodium chloride. So the procedure for this method is, firstly, in the preparation we must prepare a dense solution such as zinc chloride, and then we must do the mixing. Mix the digested sample with the dense solution in a separation funnel or similar container. Next, we must let the settling done by allowing the mixture to stand or centrifuge it at a low speed to facilitate the separation. And lastly, for the collection, we must carefully collect the supernatant which contain the floating microplastic by either using a pipette or by decanting. For the safety part for this method, we must handle dense solution with care by using PPE or ensure proper ventilation. Next one, for the filtration technique, there are two type of filter that we can use. The first one is the Wattman filter for the smaller particle, and the other one is the stainless steel sieve for the larger particle. The procedure for this method, first one is we need to do the setup by setting up the filtration apparatus with the selected filter, either Wattman or the stainless steel sieve, and then we can do the filtration by pouring the collected supernatant from the density separation through the filter. Lastly, we can do the rinsing by rinse the filter with distilled water to ensure all microplastic are collected on the filter surface. Lastly, we must carefully transfer the filter to a petri dish or other container for further analysis. And for the visual identification of the microplastic, we must do the examination under of the filter under a stereo microscope or SAM, and the criteria that we are trying to look for is to identify the microplastic based on their different size, shape, and color from the natural particle. Lastly, for the most suitable extraction method, we actually need to combine all of the method that I mentioned earlier. For the first one, we must digest the organic matter. We can use either the enzymatic digestion or acidic digestion or maybe alkaline digestion. And then we need to move to the density separation by using the zinc chloride, which is the most suitable solution for the density separation. Next, we can use the filtration to filter our microplastic according to the sample size. And then lastly, for the identification, we can isolate the microplastic by analyze it using a technique such as FTIR or maybe Raman spectroscopy to confirm their polymer types. That's all from me.
My name is Abid Numan Hazim. I'm going to present about analytical instrumentation. There are five types of analytical instrument, which are micro Fourier transform, infrared spectroscopy, Raman spectroscopy, scanning electron microscopy, chromatography, mass spectrometry, and high performance liquid chromatography. So the first one is micro Fourier transform infrared spectroscopy. It was used to identify the types of polymers present in microplastic particles. This instrument offers high recovery rate for larger microplastics, typically those greater than 20 micrometers. It provides good separation efficiency by matching infrared spectra to reference database, making it effective for identifying different polymer types. However, its sensitivity is moderate and may miss smaller particles below 20 micrometers. Despite the moderate sensitivity, micro Fourier transform infrared is widely used for qualitative analysis of microplastics due to its reliability in polymer identification. The second one is Raman spectroscopy. Raman spectroscopy is another useful instrument for microplastic analysis. It offers high recovery rates for a broad size range, including very small particles. The separation efficiency of Raman spectroscopy is excellent, providing high resolution spectra for detailed molecular identification. Its high sensitivity allows detection of particles smaller than 1 micrometer, making it suitable for comprehensive, high resolution analysis. However, it can be time-consuming and expensive, which might limit its routine use. The third one is scanning electron microscopy. Scanning electron microscopy provides high spatial resolution for studying the morphology of microplastics. While it offers excellent visual identification, It does not provide quantitative recovery rates or chemical composition analysis. Scanning electron microscopy's high sensitivity to surface morphology makes it best suited for examining the shape and surface characteristic of microplastics rather than their chemical properties. So the fourth one is gas chromatography mass spectrometry. Especially when used with pyrolysis, it provides high recovery rate and excellent separation efficiency for detailed chemical composition analysis. This instrument is highly sensitive and can identify individual chemical constituents of complex mixtures. However, gas chromatography mass spectrometry requires extensive sample preparation and is more complex and time-consuming, making it less suitable for routine microplastic analysis in environmental samples. So the last one is high-performance liquid chromatography. High-performance liquid chromatography is more suitable for analyzing dissolved organic compounds and plastic additives rather than solid microplastics. It offers high recovery rate and separation efficiency for specific compounds, but it's not ideal for intact microplastics. High-performance liquid chromatography's high sensitivity to specific compound makes it useful for analyzing plastic additives and degradation products. Based on the comparison between five analytical instruments, micro Fourier transform infrared and Raman spectroscopy emerged as the most suitable instruments for analyzing microplastic in bivalves. Micro Fourier transform infrared provides reliable polymer identification, while Raman spectroscopy offers high sensitivity and the ability to detect very small particles. This combination allows for comprehensive analysis, ensuring a detailed understanding of microplastic contamination in bivalves. Using these instruments, researchers can effectively monitor microplastic pollution and assess the potential risks to marine ecosystem and human health.
The studies show that microplastics are widespread in marine environments with significant accumulation in bivalves like mussels and oysters. These microplastics vary in size, shape, and type, but fibers are the most commonly found form. The presence of microplastic can physically harm bivalves, causing tissue damage and inflammation, and can impair their psychological function. Additionally, microplastic can carry toxic substances, including heavy metals and persistent organic pollutants, which further harm bivalves. Major sources of microplastic contamination include plastic waste from urban areas, discarded fishing gear, and wastewater treatment plants. The breakdown of larger plastic debris into microplastic significantly contribute to the contamination levels. To address microplastic contamination in bivalves, we should implement stricter regulation on plastic production and uses, promote biodegradable materials, and reduce single-use plastics. Enhancing waste management system is crucial to prevent plastic waste from reaching marine environments, which includes improving recycling rates and developing efficient waste treatment technologies. Establishing long-term monitoring programs to track microplastic pollution levels and their impacts on marine life is essential, as is supporting research initiatives to develop more effective microplastic detection and removal methods. So, in conclusion, tackling the problem of microplastic contamination in bivalves requires a multifaceted approach. By reducing plastic production, improving waste management, and supporting ongoing research, we can mitigate the impacts of microplastic and protect marine life. Thank you.